Hi, so we're going to get started working through the Chapter 6 review. This was on triangle properties, incenter, circumcenter, everything like that as well. So with question number 1, it says find BC. What I know in this is that this is perpendicular and it is bisected. And I know it's a perpendicular bisector because AB and AC are the same. Because that is true, my bisector down here, DB and DC should be the same, so DB is 10. Now, the question asked for BC, so I need to make sure I add those lengths together. 10 plus 10 in BC equals 20. For number 2, I want to find the length of AC. This is the same idea. It is a perpendicular bisector. This time, I don't know what the distance to the vertices are. Because remember, perpendicular bisectors, the distance to the vertices are the same. So I need to set this one up as an equation. 8x plus 9 equals 10x minus 9. I'm going to subtract 8x on both sides and add 9 on both sides. And I did combine 2 steps here, so make sure if you need to, you're writing those steps out separately. So then I get 18 equals 2x. Divide by 2, x equals 9. The question did not ask for what x equals 9 is. It asked for what the length of AC is. So AC was 8x plus 9. So I'm going to put 9 in for my 8. 9 times 8 is 72 plus 9 is 81. So AC is 81. Part C, again, I have that perpendicular bisector. This would be the converse of the perpendicular bisector theorem, if you want to think about those theorems. So that tells me that my base of my triangle is bisected, so those segments would be the same. So 6x plus 2 equals 7x minus 5. Subtract 6x, add 5. I get 7 equals x. And I don't really need to do anything else for that x. So what I do need to do is plug it back in. It asked me to find CD. So I'm going to do 7, which is CD. 7 times x. My x is 7 minus 5. 7 times 7 is 49. Minus 5, which is not 42, it's 44. Sorry, simple math mistake on that one. It is 44. So CD is 44. Now, if we look at number 4, 5, and 6, those are all relating to angles this time around. So the same idea works when we have angle bisectors. Remember, angle bisectors said that the distance to the sides was the same. So the distance from BD to DC. Because those are the same, I know my angles at angle A should be the same. So this asks me to find a measurement of BAC. Remember, we're going to out BAC. So I'm talking about this angle here. And so BAC would also be 37 degrees. So 5 and 6 are just applying that algebraic understanding to this. So in the diagram, AD bisects angle BAC. So we have an angle bisector. So my distance to the sides is congruent. So 4x plus 9 equals 8x minus 7. I'm going to subtract 4x on both sides, add 7 to both sides. 9 plus 7 is 16. 8x minus 4x is 4x, divide by 4. So x equals 4. And so the question didn't ask us to find x, it asked us to find BD, though we do need to find that x first. So I'm going to put 4x plus 9. I'm going to put my 4, which I solved for x here, in for my x value. 16 plus 9, which is 25. So BD equals 25. And similarly for number 6. So number 6 gives me that the lengths to the sides are congruent, so that tells me that this is an angle bisector. So I can set up my angle measurements as congruent. 3x plus 10 equals 4x minus 3. I'm going to add 3. This time I'm going a little different than I did the other time, and subtract 3x. So we get 13. Those cancel out. 4x minus 3x equals x. So x equals 13. Should make that more of a 3. And I need to plug it back in. So 3 times 13 plus 10. 3 times 13 is 36, 39. Ooh, you guys got me making lots of math mistakes today. 39 plus 10, which is 49. So this time it asks for the measurement of BAC, so this entire angle here. And I haven't done that yet. All I've found out is that this is 49 degrees. But since it's bisected, both of them should be 49. So 49 plus 49 would be equal to 98. So BAC equals 98 degrees. I want to make sure I'm reading those in direct directions and not just assuming I know what it is. For the next view, I'm talking about the incenter. When I'm thinking about the incenter always tells me that the distances to the sides are the same. It's made by those angle bisectors. So that means FN, ND, and NE would all be the same. This problem tells me that NE is 3x plus 7, and ND is 9x minus 5. Well, if those are all the same length, I can set them up as an equation. So 9x minus 5 equals 3x plus 7. I'm solving this equation. So I get 6x equals 12, or x equals 2. Question asked me to find what NF is. Now, if NF, ND, and NE are all the same, then it doesn't matter which I plug it back in for. Which I plug my x back in for. So let's just choose 3x plus 7 because it means I'm only multiplying by 3 instead of 9. So 3x plus 7 would be 3 times 2 plus 7, or 6 plus 7, which is 13. That would have to mean that since NE is 13, NF would also have to be 13. So looking at number 8, it's kind of similar. So this one I'm given N is the incenter. And since N is the incenter, I still know that that distance to the sides is the same. So ND equals 4x minus 2. NF is 5x minus 7. And I can follow the same process from number 7. So 5x minus 7 equals 4x minus 2. Subtract 4x. Add 7. So I get x equals 5. Now that I have x equals 5, I need to plug it back in. Similar to the last one, it doesn't matter what I plug it in for. So let's plug it in for 4x minus 2. So 4 times 5 minus 2, which is 20 minus 2, or 18. So I know that NE would equal 18. For number 9, this time I'm working with the centroid. And the centroid is where we have that 2/3, 1/3 rule. So the centroid tells me I have a whole length from N to A. That is, the entire thing is a length of 1. But my centroid is going to be located 2/3 from the vertex of that length. So point M is a centroid and AP equals 10. Well, AP would be 1/3 of the whole length. So I want to multiply it by 2 to get NP. So 10 times 2 would give me 20. That would be 2/3. It should be double that amount. And so NP is going to be equal to 20. But the whole length is going to be 20 plus 10, which is 30. So NA equals 30. Same thing for number 10. I'm still thinking about centroid. This time I'm looking at NP and AN that I'm trying to find. And it's giving me AP is 5. So I'm going to multiply 5 times 2 to get 2/3 of the length. That 2/3 and 1/3, remember. So I have a length of 10. So NP equals 10. Since that length is 10, the whole thing from N to A, 10 plus 5, which is 15. For number 11, we're starting to change this a little bit. So it's giving me point P is lying as a centroid. So I still know P is a centroid, the 2/3, 1/3 rule. But I'm given BL is 18. So this whole length, the entire thing, the entire part is 18. Now, I have to split that into my 2/3 and 1/3. And the easiest way to do this is to divide it into thirds by dividing by 3. So 18 divided by 3 is 6. That tells me my 1/3 length is going to be 6. My 2/3 length is going to be 2 of those 1/3, so 12. So I know that the centroid is always 2/3 from the vertex, and my vertex is L. So that tells me LP is going to be 12, and P to B is going to be 6. Those add together to get 18. Very similar process for number 12. Point P is a centroid, C to M is 9. So this whole length is 9. So I want to split it into thirds, which would be 3. And so I know that CP, because that's going to be my 1/3 part, is going to be 3. And PM is going to be 9. So CP equals 3, because that's my 1/3 section. And PM, my 2/3 section, should be 6. I think I said 9 earlier by accident. I apologize. But the total will be 9. Moving on, we have starting to talk about mid-segments. Now, mid-segments are, remember, they split the sides of a triangle into pieces. They connect the midpoints of the sides. So a mid-segment, the support GH is a mid-segment. That actually means that CH and HB and AG and GB are all congruent to each other. Now, that doesn't really matter in this case because it's not affecting our answer. Because what we really need to remember is that the mid-segment is going to be half the base of the triangle. So in this case, HG is going to be half of CA. So if HG is 8, that is half of 16. So CA would be 16. If you need to know the math for that, I would take my mid-segment and multiply it by 2 to get that whole length. So CA would be 16. Similar for the next one, I'm still thinking of that mid-segment is half the base. So I would do 5 times 2 because it's going to be my 2 times the length of that mid-segment equal to the full length. So 5 times 2, and that'll be equal to x. So x equals 10. For number 15, I'm looking at naming the side lengths from smallest to shortest. Sorry, shortest to longest. And ignore the cat fights in my background too, where it's a lovely experience teaching from home. It's very different. So I'm looking at 180, and I'm going to subtract 66 and 56. This is going to give me my remainder of an angle. So 180 minus 66 minus 56 gives me 58. So angle C is 58 degrees. Now, I know which angles are the smallest, and if I use my theorem, it tells me that the sides opposite them will be in the same order. So if I order this, I would order smallest to largest as 56, 58, and 66. 56 has an opposite side of AC. 58 has an opposite side of AB. And 66 degrees has an opposite side of CB. So my answer from smallest to longest, or shortest to longest, is AC, AB, CB. Similar idea in number 16. I want to order it from shortest to longest. Now, you could do this in reverse too. If I give you the side lengths, then you could figure out the smallest angles to the largest angles. But this one's very similarly set up. I'm going to subtract 57 and 69. I get 54. So angle C is 54. My smallest angle is angle C, and opposite is AB. My next smallest, or my medium length angle, is 57. Its opposite side is CB. And that final length, the largest angle, is 69 degrees with an opposite side length of AC as my answer. Now we can apply this to number 17 and 18. So it's asking us which angle is smaller, larger, or are those angles equal? Well, if I look at the triangle on the top, I'm given 28 degrees. And the next triangle is giving me 29 degrees for a side length. Well, 29 is larger than 28. So that tells me that angle 1 has to be larger than angle 2 because the side length, the corresponding side length, is longer. It's the same as the last one. The largest angle had the largest corresponding side length. So the largest side length has the largest corresponding angle. So for number 2, this time they're both equal. There's no side length that's longer than the other. So I have to assume that those angles would also be equal. So for 19, we're doing that opposite idea. We've taken that side length. We can order our side lengths from smallest to largest, and we're going to take the opposite angles, just like I mentioned in the previous. So angle C would be the smallest. 10 is the medium length side, so angle A would be the next. And 12 is the largest side length, so angle B is going to be the largest angle. Same thing for the next one. I'm going to put my things in order. This is just a helpful thing for me, so I don't have to look and compare the whole time. So length 29 is opposite angle B. Length 44 is opposite angle A. And 55 is opposite angle C. So my order would go from B, A to C. And that's it in terms of Chapter 6. Chapter 6 is a lot of just making sure you understand and you can think about these problems. Please reach out if you have any questions.